Okay, so this is term 5. So this is the first week, so don't worry if you don't get a lot of these right. This is more about learning the techniques, but make sure you make thorough corrections on these. So if we have a look at question 1, we've got bid mass along with multiplying and adding decimals. So thinking about our bid mass, we've got to do that multiplication first, but we're multiplying decimals. So I'm just going to do a little bit of work down here and then come back to this. So we've got to do 0.4 times 1.2. When we're multiplying decimals, we actually try and ignore the decimal points. So instead of doing 0.4 times 1.2, I'm actually going to do 4 times 12. Okay, if we know our 12 times table, we know that 4 times 12 is 48. Okay, so I know there's going to be a 4 and an 8 in the answer here. I've just got to work out whether it's 48, 480, 4.8, 0.48, and so on. We need to work out where the digits go. So I know that to get from 0.4 to 4, I multiplied by 10. Okay. And to get from 1.2 to 12, I also multiplied by 10. So what I've got to do now is to work backwards. Okay, well if I multiply by 10 twice to go back, I've got to divide by 10, but I've got to do it twice. Okay, so 48 divided by 10 twice is actually going to be 0.48. So 0.4 times 1.2 is 0.48, and then I've got to do that plus 0.6. I haven't done anything with that yet, so I need to keep that in line there. So I've got 0.6 plus 0.48. Okay, and then you might want to just do a little sum to one side for this one as well. So we write that out as column. We've got 0.6 and then 0.48. Make sure we line up our decimal points. So I can put a 0 in here. Okay, so I've got 0 at 8 is 8. 6 and 4 is 10, so I put a 0 there. Carry the 1 over here. And 1 plus 0 is 1. So the answer is 1.08. Okay, so you must have your workings because that's a non-calculator question. So don't just type it in your calculator. Okay, similar idea with this one. Okay, so we've got bid mass here. It says we've got to do the multiplication first, then the subtraction. So I've got 5 times 0.8. So again, I'm going to write out, actually do 5 times 8 to start with, which is 40. Okay, now I didn't need to change the first number at all. The 5 stayed as 5, but the 0.8 I multiplied by 10 to get 8. So I've got to divide my I've got to divide my answer by 10. So 40 divided by 10 is going to be 4. So the answer here is 4, and I've got to subtract 1.7. Okay, so again, I'll do it slightly lower here, a column subtraction here. So I've got to do 4.0 subtract 1.7, and again, really important, you line up your decimal points and then your units in the units column, tenths in the tenths column. So I've got to start by doing 0 subtract 7. I can't do that, so I'm going to have to borrow. So I'm going to cross out the 4 and just leave 3 units there and borrow 1 over here, which gives me 10 tenths. 10 take away 7 is 3. Decimal point goes in line. 3 take away 1 is 2. So the answer is 2.3. Okay. Okay. All right. So that's bid mass and decimals. Question 3, we're looking at simplifying ratio. So we started off with 5 to 35. They're asking us to get an answer 1 to something. So I need to think about how did I get from 5 to 1, and it has to be, because we're ratio, it has to be multiply or divide, so it's going to have to be divide by 5. But if I divided this by 5, I've got to divide the other side by 5 as well, very similar to fractions. And 35 divided by 5 is 7, so the answer is 1 to 7. Okay, here we're simplifying this to here. Okay, so again, how did I get from 4 to 1? I divided by 4. So we don't know this number. We know when we divided by 4, the answer was 15. So to go back, I've got to do the opposite. I've got to multiply by 4, and 15 times 4 is 60. So 4 to 60 would cancel to 1 to 15. Okay, that's the first 4 questions. Question 5 then, we've got solving an equation. So it's slightly different to the ones we've done before because we've got x's on both sides. Okay, so we need to think about this as a balance. I need to get rid of some x's. Okay, so the x's I need to get rid of, I want to get rid of the smallest number. So I've got 5 x's on this side and 3 x's on this side, so I'm going to get rid of the 3x, but I have to do that to both sides. So I'm subtracting 3x here, but I have to also subtract 3x here. So if I just do a subtraction now, I've got 5, take away 3x is going to give me 2x. This stays the same, I'm not doing anything with this 5 here. 3x, take away 3x, gives me no x's, so I don't need to write anything down. And what I'm left with here is negative 3. Okay, that negative number, that negative sign, sorry, stays with 3. So now I've got 2x plus 5 equals negative 3. Now I'm trying to leave the x's on their own, so I now need to get rid of this plus 5. To get rid of plus 5, I'm going to subtract 5 from both sides. Okay, so 5, take away 5 is going to give me nothing. So I've got nothing here. The 2x is staying as it is, I've not done anything with that. But then I've got minus 3 subtract 5, means I'm becoming more negative, so the answer is minus 8. So I've got 2x equals minus 8, and remember I'm always looking to find out what x is. So if 2x is negative 8, I need to divide this by 2 to find out what 1x is. But I can't just divide one side by 2, I've got to divide the other side by 2 as well. So minus 8 divided by 2 is minus 4. Okay, so question 6 is another equation. X is on both sides. Now again, I want to get rid of the smallest number of x's. Here I've got 6x. Here I've got negative 4x, and negative 4 is smaller than 6x, so I'm going to get rid of these. But I can't subtract x's here, okay, because that will just make this more negative. I need to add x's to get this back to 0. So minus 4, I would need to add 4 to get to 0x. So I'm going to add 4x here to cancel that out. Minus 4, add 4 gets me to 0, but I can't just do it on this side, I've got to do it to this side as well. So I get 6x plus 4x gives me 10x. The minus 9 isn't touched, that stays there. The 51 stays as it is, and minus 4x plus 4x gives me no x's. So now I've just got x's on one side, and I want to just leave the x's on their own here. So I need to get rid of this negative 9. Again, to get from negative 9 to 0, I need to add 9. So I'm going to add 9. Okay, but I've got to do it to both sides. So this here is going to cancel out. I'm going to be left with just 10x on this side. Okay, and 51 plus 9 gives me 60. So now I know that 10x equals 60. Now I'm trying to work out what 1x is. So to get to 1x, I need to divide by 10. So 10x divided by 10 gives me 1x. Okay, so just go back to where we were before. 10x divided by 10 gives me x. 60, I have to divide by 10, it gives me 6. So x equals 6. Okay, let's move on to question 7. So this question is a new one. We've not seen anything like this before. So it says, does the point 4, 4 lie on the line y equals 2x minus 4? So if you remember, with a coordinate, the first number is your x number, the second number is your y number, and this is the equation of a straight line. So what we need to do is we need to take the x number, which in this case is 4, so I've written here x equals 4. We're going to substitute that into this equation and see what y comes out as. So we started with y equals 2x minus 4. Okay, and we're going to substitute the x for 4. And what we've got to remember is that 2x means 2 times x. So my next line is going to be y equals 2 times, and instead of x, I'm going to write in 4 minus 4. Then we need to use our BIDMAS rules that say, do you multiply first? So we do the 2 times 4, which gives us 8. So y equals 8 minus 4, and then straightforward, you can see y equals 4. Okay, so the coordinate would be x equals 4, and then it says y equals 4. So what I can write now to finish this question off is that yes, 4, 4, okay, x equals 4, y equals 4, does lie on that line. Okay, if y had come out as something different, a different number, then 4, 4 wouldn't be on that line. But as we can see, when x is 4, y is 4, so therefore 4, 4 lies on that line, y equals 2x minus 4. Question 8 is similar. Okay, just a different line and a different coordinate. So this time my line is y equals 19 plus 3x. And this time we're asked to look at the coordinate 328. So my x part of that is x equals 3. So again, I'm going to substitute x equals 3 into here. So we're going to start with y equals 19 plus 3 times, and x is 3. So it's going to be y equals 19 plus 3 times, and the x has now become 3. Again, BIDMAS rules say we do the multiplication first. So we get 19 plus 9. 19 plus 9 is 28. So y equals 28. So when x is 3, y equals 28. That is the coordinate we were given to start with, 328. So again, we can say exactly the same, that 328 does lie on the line y equals 19 plus 3x. Okay, question 9, we're looking at sequences and nth terms. So the first one is something you've seen before. Okay, to get from 2 to 4, we add 2. To get from 4 to 6, we add 2, and so on. And when we're adding 2, we know that's like the 2 times table. So the first part of our rule is 2n. Well, if you have a look, actually this is the 2 times table, so I don't need to subtract or add anything onto it. It is 2n. So 2 times 1 would give me 2, 2 times 2 would give me 4, and so on. Okay, this one is slightly different because we're not adding this time. To get from 0 to negative 6, we're subtracting 6. To get from negative 6 to negative 12, we're subtracting 6, and so on. So, what times table is this like? Well, it's like the negative 6 times table. So, the first part of my nth term is negative 6n. Okay, so what it's useful to do now is to write out that times table. What does the negative 6 times table look like? Well, 1 times negative 6 is negative 6. 2 negative 6s are negative 12. Then it's negative 18. and then it's negative 24. So I've got to look at those blue numbers, that negative 6 times table, and say, how do I get to the numbers here? How do I get from negative 6 to 0? Well, you would add 6. How do you get from negative 12 to negative 6? Add 6. Negative 18 to negative 12, add 6. So the nth term is minus 6n, add 6. Now that was a difficult one, so don't worry if you didn't get that. But again, just make those corrections, make sure you understand what's going on. Question 11, we're given an equation of a straight line, and we're told to find the gradient of the line. Now be very careful with this one. So we have learnt that the number in front of the x gives the gradient, but that's only true when we are looking at it in the form y equals x, some x's plus a number. And at the moment we've got 2y. So what I've got to do is to change this whole equation into y equals something. So how do we get from 2y to y? Well, we would be dividing by 2. So the same as in equations, whatever I do to this side, I've got to do to this side and everything on this side. So I'm going to divide minus 6x by 2. That will give me minus 3x. I'm going to divide the plus 1 by 2, which will give me half, or 0.5. So this is the same as this, but now it's in this form, y equals minus 3x plus half. I know the gradient is the number multiplying the x, so the gradient is going to be minus 3. Okay? Question 12, we're then asked to find the y-intercept of this line. So same idea, it has to be in the form y equals, and at the moment it's 3y equals. So how do I get from 3y to y? I have to divide by 3. If I'm dividing that by 3, I've got to divide everything by 3. So 12x divided by 3 gives me 4x. And 15 divided by 3 gives me 5. Now the y-intercept, if you remember, is this bit at the end that we add on to the x's, the plus 5. So the y-intercept, okay, is going to be 5 or plus 5. Okay, question 13, expressing 16 out of 40 as a percentage. So 16 out of 40 as a fraction is like this. And remember, percent means out of 100. So I need to try and change that bottom number to 100. And there's lots of ways you could do this. Okay, I've gone with just halving both of these numbers here because it's very difficult to get from 40 to 100. But if I halve these numbers, okay, I get 8 out of 20, and then 20 I know is very easy to get to 100 by multiplying by 5. So as long as I do the same to the top and the bottom, okay, if I multiply the top by 5, I've got to multiply the bottom by 5. That gives me 40 out of 100, and 40 out of 100 is 40%. Here we've got 85 out of 200, and again, percent needs to be out of 100, so I had to divide that denominator by 2. So if I did that to the bottom, I've got to do the same to the numerator. So 85 divided by 2 is 42.5, which gives you 42.5%. Okay, question 15. Actually, I'm going to stop this one and do it on a new. Okay, question 15 then. We're adding mixed numbers. So I'm not going to worry about the whole numbers. I'm going to keep those as they are, the 2 there and the 2 there. I'm just going to look at the fractions. And remember, when we're adding fractions, we need a common denominator. At the moment, we've got 2 different denominators. So I need the lowest common multiple of 4 and 3. Well, the easiest way is just to multiply the 4 and the 3, and we get 12. So I now need to think about, what did I multiply 4 by to get 12, and that was 3. So I need to multiply the top number by 3, which gives me 3 3s are 9, so that's 9/12. And over here, what did I multiply the 3 by? Well, I multiplied that by 4, so I need to multiply the top number by 4, which gives me 4. Now I can add the whole numbers. 2 add 2 is 4. I can add the fractions. 9 add 4 is 13. So I've got 4 and 13/12, but I have a top-heavy fraction here, so I need to change that to a mixed number. So 13/12, well, I would get 1 whole out of that with 1/12 remaining. So if I add that 1 whole, I get 5 and 1/12. Okay. Here we're multiplying mixed numbers, and multiplying and dividing mixed numbers you have to have as top-heavy fractions. It's very difficult to do it as this is as a mixed number. So the first thing we're going to do is turn 3 1/7 into a top-heavy fraction. So 3 holes, if I was cutting each of those holes into 7 pieces, I would have a total of 21/7. And then I've got this extra 1 here, this 1/7 here, which gives me 22/7. Okay, similarly, okay, on the other one, just get rid of this. Let me, no. There we go. Okay, 2 1/2. Well, if I had 2 holes and I cut them into halves, that would give me 4 halves. Plus this extra 1 here gives me 5 halves. Okay, so I've got 22/7 times 5 over 2. Now when we're multiplying, we multiply the top, multiply the bottom, but you need to be a little bit careful that you don't make sums too difficult for yourself. And so the first thing we want to do is, can I do any cancelling? Now there's nothing that will cancel with 22 and 7, and there's nothing that will cancel with 5 and 2, but I can be looking across to look for things to cancel. And what I can see here is 22 and 2 have got a common factor of 2. So if I have a look at how many 2's go into 22, well that's 11. How many 2's go into 2? Well that's 1. So that makes my multiplication a little bit easier. I've got 11 times 5 on the top, which is 55, and 7 times 1 on the bottom, which gives me 7. So it's 55/7, but I want to leave that as a mixed number. So I need to work out how many 7's go into 55. Well, 7 7's are 49, so that's 7. And I would have 6 remaining, so that would be 6/7 left over. So it's 7 and 6/7. Question 17, we're rounding to one significant figure. So I've got the number 39. Now one significant figure means I'm looking at the highest, I'm looking for the highest place value. Okay, so I've got units here and tens here. So it's this number I'm interested in. And this number, the units column, is going to be filled with zeros. Okay, so if I think about it, what I'm doing is I'm cutting off here. Okay, so I've got to think now, is 39 closer to 30, okay, or 40? So we should recognise that 39 is closer to 40, so 39 would round to 40 to one significant figure. So I've got a number in the tens column, but the units column is filled with zeros. Okay, similarly with this one. Okay, slightly, you have to think a little bit more carefully with decimals. So we've got 0.941. And I'm looking for the most significant digit. Now, there's nothing in the units column, and there's nothing in the tens column and so on, so I'm not worried about any of these. My first significant digit is this one here, okay, in the tenths column. So my cut-off point is going to be here, Okay, so it's either going to be 0.9, or I would round up, and the 9 would round up to 1.0. Now I need to look at this digit to determine whether we stay at 0.9 or whether we go up. And if you remember, 4 and below means this stays at 0.9, 5 and above would mean you round up to the next digit, which would be 1.0. So this is going to be 0.9. That's a difficult one. Okay, there we go, 0.9. Okay, 25% of 12. There's lots of different ways you could do this. But if you think about it as 25% is the same as a quarter, you just need to do 12 divided by 4 is probably the easiest way to do it. Okay, and 12 divided by 4 is 3, so 25% of 12 is going to be £3. Okay, you might want to find 50% and halve it, or you might want to find 10% and 5%, it's up to you, but this is probably the quickest way of doing it. So the answer is £3. 1% of £33, well 1%, to find 1% you divide by 100, so I'm going to do 33 divide by 100, okay, and when we divide by 100, all the digits move 2 places to the right, so it's going to be 0.33, and we're working in money, so I'm going to put a pound sign in, and it's £0.33 or 33 pence. Okay, so mark out of 20 and send that in to me via email.